Welcome to the deep dive. If you really think about it, our entire history with machines has been based on this idea of rigid obedience.
It's a master-servant relationship, really.
Exactly. We give a command and the machine executes it perfectly, step by step, no questions asked. You tell a spreadsheet to run a calculation, it just does it.
hmm Or a factory robot,
Mhm.
weld point A, then B, then C. It doesn't wonder if there's a better order or if the metal is flawed.
Right. It never ever understands the why. It doesn't have the context, the purpose behind the task.
Well, that's the thing, isn't it? That whole era is, well, it's starting to feel very old, very fast.
It is. We are now moving into a fundamentally new age, the age of artificial intelligence agents. These aren't just tools anymore. They're systems built to perceive, to understand context, to reason about a goal, and then to actually make decisions on our behalf.
It's the dawn of real digital autonomy.
It is, and that's our mission today. We are doing a deep analysis of some really definitive source material, understanding AI agents, intelligent workflows, and autonomy. Our goal here is to just cut through all the hype you're seeing everywhere.
Which is a lot.
It's a massive wave. We want to give you the foundational structural knowledge you need, basically, the shortcut to being genuinely well-informed about this digital revolution and what it really means for you.
And maybe we should just ground this whole conversation right from the start. If you take away just one single idea from this intro, let it be this one.
Okay.
An AI agent is, for all intents and purposes, your new digital teammate.
A teammate. I like that.
Think of it like a specialized, goal-driven employee that lives in the cloud. We are not, and this is so important, we are not talking about a clever app that just responds to your text prompts. The absolute key difference for an agent is that its whole architecture, its entire reason for being, is to accomplish something, to achieve a complex, multi-step goal that you've set for it. And it does that by planning and acting on its own, without you having to check in every 5 minutes.
That's a huge distinction from a tool to a teammate. That's the monumental shift we're talking about.
It really is.
Our sources really stress that this historical context is key. We're moving beyond what we used to call simple automation. Just duplicating a rigid, pre-programmed human task.
Right. That's just a script.
The agent era is defined by systems that perceive what's going on around them, reason about the best thing to do next, and then execute that plan autonomously.
And that really is a fundamental move toward what you could call truly intelligent workflows. I mean, the formal definition of an AI agent, when you really break it down, is surprisingly elegant. It's very structured, very sequential.
Okay, let's hear it.
We define it as a self-directed system that's always continuously operating on what we call the PRA cycle: perception, reasoning, and action. And here's the critical part. If any one of those three pieces is missing, you don't actually have an agent. You've just got a very advanced script, or maybe a fancy chatbot.
So perception, reasoning, action. Let's break that down. What's the perception piece?
So the cycle always starts with perception. This is, in the simplest terms, the agent's senses. It's how it takes in information from its environment.
And that environment can be anything, digitally speaking.
Absolutely anything. It could be raw text from an email. It could be high-resolution images from a security camera, streaming audio from a meeting.
Or even sensor data from a factory floor.
Exactly. Or, complex financial data from a company's ERP system. This perception layer is so critical because it's what gathers all the necessary context to even begin to understand the problem it's supposed to solve.
Okay, so once it's perceived the situation, gather the data. The second step, reasoning, that has to be the core intelligence part, right?
That's exactly right. Once the agent has all that context from the perception phase, the reasoning engine kicks in. And this is where the magic, if you want to call it that, really happens. Based on the big picture goal you gave it, the agent decides what sequence of steps is logically required to get there.
Yeah.
This is all about planning and interpretation. It's using its internal models, its knowledge base, to simulate different outcomes, anticipate potential problems.
So it's not just following a rigid path, it's trying to find the best path.
Precisely. It's determining the optimal way forward. And that's the difference between a machine that just calculates and a machine that actually thinks about how to use that calculation as part of a strategy.
And then after all that thinking and planning, it has to actually do something. That's the action phase.
That's the final step in the loop. The agent executes the plan. And this almost always means it has to interact with the outside world in some way, not just, spit out some text.
It needs tools.
It needs tools. It might interact with a specific database. It might leverage an external API from another service. The agent is ultimately defined by its ability to get things done.
And those three things, perception, reasoning, action, they form a continuous loop.
A continuous loop. And if we look at the sort of qualities that define this whole system, it really boils down to three things. The agent is fundamentally goal-oriented. It has a clear mission.
Okay.
It's autonomous within boundaries. It can act on its own, but you, the human, set the guardrails. And most importantly, it's capable of continuous learning. It feeds the results of its actions back into its own reasoning loop to get better over time.
I think the best way to make this PRA loop feel real is to use some of the concrete scenarios from the source material. Let's stick with that example of complex financial compliance. It seems like a perfect fit for agents.
It's a great use case.
So let's start with perception. Imagine you've got an AI agent working for an accounting firm. Its primary job, its perception task, is to monitor all the incoming client data.
Right, and that's not as simple as it sounds.
Huh? Not at all. We're not just talking about reading emails. This involves things like optical character recognition OCR on huge stacks of scanned receipts and invoices. Just messy, unstructured visual data.
And it has to turn all of that mess into structured, usable information.
Exactly. And at the same time, it might be monitoring a shared folder for new data files, or even listening to transcribed audio from client interviews. It's taking in a ton of different data types.
Okay, so that's the complex stream of data it is perceived. Now that flows into the reasoning phase, and this, I think, is where the agent truly earns its keep.
Yeah.
So let's say the goal is correctly categorize all client income and expenses for tax filing. The agent doesn't just match keywords like travel or office supplies.
It's got to be more nuanced than that.
It has to be. It has to interpret regulatory complexity. For example, it might see a receipt for a meal. Now it has to reason. Was this meal during a business trip? Does it fall under the client's internal travel policy? Does it qualify as a deductible business expense under the current, very complex tax code?
A code which could have contradictory or subtle rules.
Precisely. That kind of interpretation, that requires deep contextual logic. It's not just pattern matching.
Okay, so after all that categorization and interpretation is done, we get to the action phase. And the source gave a really specific example here. Submitting the process data to the FBR portal, the Federal Board of Revenue.
A very real-world high-stakes action.
Totally. So the agent, having planned everything out, now has to autonomously orchestrate this whole sensitive sequence of actions. It has to securely log into the government portal with its credentials.
Which can be a clunky, slow website, by the way.
Oh, for sure. It has to navigate those complex web forms, upload the right documents, map all the data it categorized into the specific fields the portal needs, and then finally hit submit.
And that's a lot of things that can go wrong. It needs to handle potential errors, timeouts, and validate everything before that final submission. It's a true end-to-end task.
And this is where that loop you mentioned becomes so clear.
Yes. The moment the data is submitted, the agent's perception layer is already active again. It's monitoring for a response.
Did it get a confirmation receipt?
Or did it get an error message? Maybe it says required field missing. The agent perceives that new piece of information, reasons about what it needs to do to fix it, like, oh, I need to go back and add the client's license number, and then it takes another action to self-correct.
And it keeps doing that until the goal is achieved.
That ability to self-correct and just relentlessly pursue the goal until it's done, that iterative PRA cycle is the defining feature. It elevates it so far beyond a simple automated script. The machine isn't just doing what it was told, it is working toward an outcome. And it's adapting to problems in real time.
That continuous looping is the key. But I have a question about something you mentioned earlier, the autonomous within boundaries constraint.
Ah, yes. The guardrails.
Yeah. If this system is constantly adapting, how do we make sure it doesn't just wander off the path? In that tax scenario, for instance, how do we prevent the agent from deciding that the best action is to sell off some assets to pay a tax bill it just invented?
That is probably the most essential question when it comes to governance and safety. And the boundaries are really enforced through two main mechanisms.
Okay.
First, the goal definition itself has to be incredibly specific. If the goal is file tax returns, the system's logic can't suddenly jump to manage investments. The scope is tight.
So clarity of purpose is the first line of defense.
It is, but the second one is much more technically robust. The boundaries are enforced by the tool interfaces. The agent is only given API access to very specific sandboxed environments.
So you only give it the keys it absolutely needs.
Exactly. If the agent's tool access is limited to the FBR portal and the company's internal expense database, It literally does not have the technical ability, the keys, to log into the client's brokerage account or their personal bank. The human designer retained absolute control over what actions are even possible.
So autonomy is granted through a clear goal, but it's constrained through limited tool access. That makes a lot of sense. That provides some crucial context for the architecture.
It's foundational.
Okay, let's move on to a really critical point of confusion that I think a lot of people have. Anyone who's used a modern large language model, through something like ChatGPT or Gemini, they see this incredibly capable system. It can write code, it can analyze data, it can have these very complex conversations, and they might naturally think, well, isn't that an agent?
It's a very common question.
But our sources draw a very clear, very functional line in the sand between a traditional chatbot and a true AI agent. I think we need to unpack that distinction.
Yeah, we absolutely do. It's a crucial clarification because, while the underlying LLM technology might be the same, the way it's used, the operational architecture and its purpose are completely different.
Right.
The source material gives us a great comparison table that really highlights 4 major structural differences.
Let's go through them.
Okay, first, let's start with purpose. A chatbot's primary purpose is, and always has been, dialogue. It's optimized for conversation, for Q&A, for generating content. The quality of the interaction is its main metric.
But for an agent?
For an AI agent, the purpose is singularly focused on goal completion, task execution. An agent's success isn't measured by how well it writes, but by whether or not it successfully accomplished the task. That's a huge difference in focus.
Okay, purpose is number one. What's the second big difference?
The second one is memory architecture, and this is a really deep technical divide. A chatbot, unless it's a very custom build, typically operates with a very short session-based memory.
Right. It remembers what you said a few minutes ago in the same conversation.
Exactly. Yeah. It might remember the context of the last few thousand words, but once you close that window, that context is often just gone or generalized.
But an agent can't work like that.
An agent can't. It requires persistent and contextual memory. This memory, its knowledge base, is usually stored externally in these specialized databases. You often hear them called vector databases.
And what does that allow it to do?
It allows the agent to instantly retrieve and understand the history of its past actions, your company's internal knowledge, user preferences, long-term project status. This deep, persistent memory is what allows a tax agent to remember what deductions you used 2 years ago or what compliance issue came up last quarter.
That memory difference seems to lead directly to the third point.
It does. It leads directly to the difference in capability, which is tool use. A really high-end chatbot might be able to, say, browse the web or use a simple image generator.
Yeah.
An agent, by necessity, requires and possesses full, sophisticated API and function access.
Yeah.
It has to be able to securely connect to your organization's entire technology stack. Your CRM, your financial systems, your email servers, whatever it needs. It has the keys to act inside your entire digital ecosystem.
And that brings us to the final and probably most important distinguishing feature.
Autonomy.
Exactly.
A chatbot is fundamentally passive. It waits for user input, and then it responds. An agent is proactive. It initiates and completes tasks.
So it can act on its own without being told to in the moment?
Absolutely. If it perceives that some condition for its goal has been met, or maybe a critical deadline is coming up, it will autonomously wake itself up, reason about the situation, and initiate the necessary action, even if the human user is offline, even if you're asleep.
Let's use that illustrative example from the source again, because I think it makes it so clear. Chatbot is like an HR FAQ tool.
Right.
You ask it, what's our company policy for vacation days, and it gives you the answer. That's dialogue. The task is done.
The interaction is complete.
But the agent is the end-to-end payroll manager. Based on its goal, it perceives an employee's hiring date, it reasons about how much leave they've accrued, it initiates the calculation by calling the HR database API, it then performs the deposit action through the bank's API, and then it proactively sends a notification to the employee after the deposit has cleared. It managed a whole complex financial and administrative goal from start to finish.
And that holistic capability is why agents are suddenly at the center of so much business strategy.
It is, which brings us to the really critical question. Why now? Why are they exploding right at this moment? And it's not just about the technology itself. It's a convergence of strategic and operational factors.
Okay.
The first, and I think the most profound strategic shift is happening inside organizations. As the sources point out, smart companies are moving beyond thinking about work in terms of these big monolithic jobs.
Right.
They're doing something you could call workflow decomposition. The source puts it very bluntly. The world has shifted to tasks, not jobs. So they're breaking down a complex role like marketing manager or compliance analyst.
Into hundreds of tiny, granular, really well-defined microtasks. And these microtasks are being specifically engineered so they can be handed off to a specialized AI agent for execution. High volume, repeatable, precise execution.
That's a fascinating way to look at it because it completely reframes the role of human capital. Humans are kept for the big picture strategy, the creative judgment, the relationship building,
The things humans are uniquely good at.
while the agents handle the massive administrative and procedural load.
Precisely. And this decomposition makes companies way more agile. It reduces the cost of doing all these repeatable processes, and it lets them scale in a non-linear way. If a compliance rule changes, they just update one agent's goal definition. They don't have to retrain an entire human department across 10 different offices.
And at the same time, the barrier to even getting into this has just completely crumbled. The sources point to two huge democratizing factors that are driving this adoption.
Yeah, this is key.
First, the rise of no-code platforms. I mean, for decades, if you wanted to build something like this, you needed a dedicated team of very specialized, very expensive programmers. Now, anyone who has a clear, measurable goal can use these drag-and-drop interfaces, use natural language prompts to build and deploy their own specialized agent.
And this just moves the power of AI out of the R&D lab and puts it directly into the hands of the everyday professional, the subject matter expert who knows exactly what problem they need to solve.
It's a massive accelerant.
It is. You no longer have to write a complex Python script to tell the agent how to call an API. The no-code platform just handles all that complexity for you. The professional just defines the what and the why, and the platform builds the how.
And the second factor is just the ubiquitous nature of APIs everywhere.
Yes.
The modern internet is just this huge interconnected network of services. Every major platform, whether it's Google Sheets, Salesforce, your bank, logistics trackers, they all expose their functions through these application programming interfaces or APIs.
Which means fundamentally that almost every digital service in a modern company is already agent-ready.
Exactly. The agent isn't operating in a vacuum. It has the potential to just seamlessly plug into the entire digital nervous system of a business. API access is basically the modern version of a machine having access to all the tools in a workshop.
The agent just needs to be able to read the API's instructions and then execute the right function call, which, it turns out, modern LLMs are extremely good at doing.
But let me push back on that a bit. If we are giving these autonomous systems, as you said, full API and function access, basically the keys to the kingdom, what are the security implications? That sounds terrifying.
It is.
We're talking about giving something the ability to transfer money, delete databases, change regulatory filings. How does the architecture of adoption deal with that level of risk?
That is the critical question. And any responsible deployment depends on the answer.
Right.
The architecture has to have these really stringent security wrappers around the tool interfaces. Firstly, the agent always operates under what's called the principle of least privilege. It only gets access to the absolute minimum set of APIs it needs for its specific goal, nothing more.
Right.
Secondly, all the critical function calls have to be pre-validated. Before an agent can execute an API call that, say, transfers a large sum of money, that action sequence has to be routed through a human approval step, or at least through a very stringent internal policy check that's monitored by other systems.
So it's autonomy, but it's not unchecked autonomy.
It's autonomy within a cage of auditable security. That's the only way this works.
Okay. And then let's just circle back to the pure technology that's making this all possible.
Right, the muscle behind it. We mentioned multimodal models. This is so important. The convergence of models that can handle text, vision, and audio all at the same time. Your GPT-4o, your Gemini, Claude 3 Opus. This allows the agent to build a more holistic, complete picture of its environment.
So an agent analyzing a business deal isn't just reading the text of the contract anymore.
No. It can also analyze the financial projection charts, which is vision data, and listen to the recorded board meeting minutes, which is audio data, all at once.
And that cross-domain perception, that has to be what unlocks the ability to tackle these really complex, real-world problems that are never just about text.
Absolutely. And the final factor is just pure economics, falling compute costs. The cost of running the massive, complex calculations for these deep reasoning models has just plummeted.
So what was once only for elite, huge organizations
Is now accessible on a subscription basis to small and medium-sized businesses. And that accessibility, that is what transforms a cool piece of technology into a true societal revolution.
Okay, so to transition into the how, we need to really dissect the actual structural components of autonomy.
Yes. We've said an agent's intelligence isn't magic, and it's not. It's a very disciplined, layered architecture. For an agent to perform autonomously, there are 5 essential components that have to work together seamlessly.
The blueprints for building a digital teammate.
That's a great way to put it. Let's go through them one by one. Number 1, goal definition.
This sounds obvious, but I have a feeling it's more complicated.
It sounds obvious, but it is the single greatest reason for success or failure. An agent is completely worthless if its goal is vague. If you tell an agent, help my business grow, it's going to fail. It doesn't know what to do.
Too broad.
Way too broad. You have to define a clear, measurable, time-bound intent. Something like, increase the engagement rate on all social media posts by 15% in the next 30 days by automating content optimization. That specificity is the blueprint that guides every single decision the reasoning engine makes.
Okay, so if goal definition is the blueprint for autonomy, how do we handle the inevitable situation where the human user defines a goal that is a little ambiguous? Or what about a goal that changes every day in a really fast-moving project?
That's a great question, and that's where the sophistication of the reasoning engine and the feedback loop really come into play. A well-designed agent will start by perceiving its environment and then reasoning about that initial ambiguity.
So it won't just guess and start working.
No, it might take a preparatory action. It might actually seek clarification from you, the human user. It might ask, to achieve what you're calling optimal performance, should I prioritize speed, cost, or quality?
Ah, so it asks for help in defining the goal more clearly.
Yes. That immediate clarification step before it commits to a long chain of actions is often the sign of a really well-designed, human-centered system.
Okay, so that's component one. What's number two?
Component number 2 is the knowledge-based memory. We touched on this idea of persistent memory earlier, but let's get into the mechanics a bit. This is the foundation of everything the agent knows and is often stored in those specialized vector databases we mentioned.
Right.
So when an agent perceives a new input, let's say a query from a client, it doesn't just rely on its general knowledge from its initial LLM training.
It grounds its knowledge in specifics.
Precisely. It uses a technique you often hear called retrieval augmented generation, or AG. The agent does a quick search of its vector database, which has all of your specific, proprietary historical data, all the client notes, the internal company policies, past mistakes it's made.
And that allows it to answer with information that is grounded in your company's reality.
Exactly. It's not just giving a generic or worse, an inaccurate and outdated answer based on what it learned from the public internet 2 years ago.
Yeah.
This memory is what transforms a generic LLM into your specialized, knowledgeable teammate.
Okay, so if the knowledge base is the agent's brain, then the next component, the reasoning engine, must be its internal strategist. How does it actually figure out the sequence of steps to take?
The reasoning engine is the logic system that plans the execution. It takes the perceived environment, compares it against the goal, and checks the available knowledge. Modern agents do this planning through some really clever techniques, often something called chain of thought prompting.
Chain of thought.
Yeah. Instead of just jumping straight to a final answer, the agent is basically instructed, through very careful prompt engineering, to internally talk itself through its logic, step by step.
So it thinks out loud, but inside its own code.
That's a perfect analogy. So if the goal is submit the Q4 report, the reasoning engine first generates its own internal plan. 1, retrieve the Q4 data from our SQL database. 2, format that data into the compliance template. 3, check that template against the latest regulatory standards. 4, use the API to submit it.
And by creating that explicit internal chain of thought.
It can self-evaluate, it can catch its own errors before it acts, and, maybe most importantly, it gives a transparent, auditable trail of its decision-making process that the human supervisor can look at.
That chain of thought approach is so critical for transparency. It helps us get away from that black box problem we always hear about with AI.
It's a huge step in that direction, absolutely. Yeah. Okay, so the fourth component is the tool interfaces. We've established the agent needs to act, but let's talk about the technical side of that. The agent has to be able to perform what's called function calling. If its reasoning engine decides step 1 is retrieve data, it needs to be able to translate that logical step into a very precise programmatic instruction, an API call, that the external database can actually understand and execute. The tool interface is what manages that translation layer.
And I imagine that interface has to be pretty robust.
Oh, it's incredibly complex. It has to handle secure authentication, It has to be able to understand error messages. What if the database times out or says incorrect parameter? And it has to ensure the agent only ever uses the functions it's explicitly allowed to use. The integrity of that tool interface really determines the safety and effectiveness of the entire system.
Okay, and that brings us to the fifth and final piece, the feedback loop, the mechanism for continuous improvement. We talked about self-correction, but how do we make sure the agent doesn't start learning bad habits, maybe from imperfect human feedback? A phenomenon I've heard called model drift.
That is a primary concern for any autonomous system that's actually deployed in the real world. The feedback loop has to be very carefully structured to take in both machine feedback like system error logs and submission receipts and validated human feedback.
So you need to prevent that model drift, whereas performance actually gets worse over time because it's learning from bad data.
Right. And you do that with a rigorous process of validation. This usually means you have human reviewers who regularly audit a small sample of the agent's actions, they score its success against key performance indicators, and then they feed that high-quality, curated feedback data back into the agent's knowledge base.
So it's an ongoing maintenance job.
It's an ongoing maintenance requirement. If the agent fails to meet its goal, that failure gets logged, the reasoning engine analyzes why it failed, and that lesson is incorporated for the next attempt.
The loop demands discipline.
So when you put all 5 of those elements together, a clear goal, grounded knowledge, strategic reasoning, operational tools, and a self-correcting feedback loop, that's when an agent achieves true autonomous performance. That's the formula.
And the source material makes a really important point to stress that this autonomy always exists under human supervision.
Always.
I really like this concept of the agent as a co-pilot. It's this powerful engine that can execute complex flight plans, it can handle all the tedious checklists, manage all the minute-by-minute details.
But the human captain is always the one who retains ultimate strategic direction, final accountability, and crucially, the ability to grab the controls and intervene if the agent's planned actions start to diverge from the mission's intent.
It democratizes capability without giving up responsibility.
And that idea leads us perfectly into the next big frontier, multimodality. Up until very, very recently, even the most advanced agents were basically trapped in the world of digital text.
Right.
The next generation of agents can interpret speech, images, and video simultaneously. And this allows them to connect the digital and the physical worlds in real time.
And that's a breakthrough because real-world tasks are never just one thing. They're inherently multimodal.
Exactly. Think about a human quality inspector on a manufacturing line. They don't just read a text checklist. They look at the finished product, which is vision. They listen for any weird sounds coming from the machinery, which is audio. And they cross-reference the batch codes, which is data. A multimodal agent can now do all of that at once.
Let's run through some of those expanded multimodal examples because I think they really highlight the complexity here.
Sure.
Start with that combined data stream. An agent that's monitoring a legal brief is now reading the text, sure, but it's also processing the embedded graphs and charts with its vision capabilities to verify the numerical claims.
And it can even analyze the tone and the key points from an attached video deposition, which is audio data, to build much more holistic legal strategy.
Right. The visual and the audio cues are now being weighed right alongside the text when it's doing its reasoning.
And think about healthcare. A diagnostic agent isn't just reading the typed symptoms in a patient's electronic health record. It can analyze the raw imaging data from an MRI or an X-ray, which is vision. It can listen to a recording of the doctor's spoken notes from the patient visit, which is audio. And it cross-references all of that against its massive database of medical research papers, which is text. This convergence of different domains just dramatically increases the scope and the accuracy of its perception.
Or, even think about the administrative layer of media creation, like what we're doing right now. A podcast producer agent doesn't just transcribe the audio of our conversation using a tool like Whisper.
No, it can do more.
It can analyze our vocal inflection and volume to identify the moments where we get excited or make a really critical point. It can use that data to automatically pull out key quotes as text, and at the same time, it could generate accompanying visual assets or marketing images using a tool like Stable Diffusion, all based on the themes it identified.
So it's audio, text, and visual creation all orchestrated by one autonomous system.
And the crazy thing is, this is all highly accessible right now. The commercial availability of these really powerful multimodal models like GPT-4o, Gemini, and Claude 3 Opus, it means that any developer or even just a tech-savvy professional can start building these complex cross-domain agents today.
Yeah, we are way past the era where this kind of capability was locked away in some specialized research lab. It's out in the wild.
So we've established the structural how. Let's pivot now and focus on the impact. The speed and the depth with which these AI agents are transforming these really complex, traditional human-only domains is it's astonishing.
Mm.
And the source material highlights several transformations that show these agents aren't science fiction, they are operating right now. Take
Absolutely.
the legal field. It's a domain defined by just vast complexity and incredibly precise language. We're already seeing agents like the legal argument builder that can draft foundational legal motions in minutes.
And that is transformative, because the agent grounds its reasoning in these massive databases of case law and precedents. It can do tasks that used to take junior associates dozens, if not hundreds, of hours,
Like what?
like summarizing discovery documents, identifying potential conflicts of interest, or generating the first drafts of procedural arguments. It's a massive productivity boost.
And in finance and compliance, which is so rule-bound and goal-oriented, agents are just a perfect fit. The source mentioned the PackFiler AI tax assistant.
A great example.
It's a powerful case of an agent that automates compliance from end to end. It perceives all the incoming financial documents, it reasons about those complex and constantly shifting tax codes, and then it acts by securely interfacing directly with the regulatory portals.
And the big benefit there isn't just speed. It's a massive reduction in the human error rate that's always associated with high-volume data entry and complex rule interpretation.
The disruption in education is also really interesting because it's so personalized. The digital future AI school tutor, for example, it operates on that continuous feedback loop we talked about.
Oy.
It perceives a student's performance across all these different metrics, quiz scores, how much time they spend on a concept, what mistakes they keep making, and it reasons about that student's unique learning gap.
And then it acts by generating a totally personalized teaching method. Custom practice problems, different explanations, all tailored to that one individual student's needs and their pace.
In healthcare, the transformation is really about communication and accessibility.
Yeah.
The diagnostic explainer agent.
Yes.
It takes the highly technical, jargon-filled language of a complex medical report. You know, the kind filled with acronyms and anatomical references that no one understands, and it just converts it into simple conversational language that a patient can actually understand.
And that simple action can have huge effects. It drastically improves a patient's understanding of their own condition, their adherence to the treatment plan, and just their overall confidence in the care they're receiving.
And we already touched on media production, but beyond just transcription, the podcast producer agent can automate the entire workflow of creating assets.
It's not just transcribing and pulling quotes. It can manage the whole asset library.
Mhm.
It can schedule promotional content to go out on different platforms using their APIs.
It can even analyze listener feedback to recommend changes to the content strategy. All of it done autonomously, all in pursuit of the goal of maximizing audience engagement.
The consistent theme across all of these domains is that AI agents are boosting efficiency, they're cutting down on errors, and they are dramatically speeding up professional output in ways that were just, frankly, unthinkable even 5 years ago.
And that right there is where the philosophical and the very practical challenges start to come in.
Yes. As these systems get woven into our critical infrastructure, their autonomy has to be balanced with incredibly rigorous design standards. We have to pivot now to the philosophy of autonomy and the requirements for governance. We have to focus on the essential questions the source material raises.
Because when an autonomous system is executing these complex tasks, the question of responsibility is paramount.
It is, first and foremost, accountability. If that tax agent makes a mistake on a regulatory filing and it results in a massive fine, whose legal liability is it? Is it the user who set the vague, high-level goal?
Or is it the developer who designed the reasoning engine? Or the company that deployed the agent?
Exactly. It's not a simple answer.
And that complexity, that kind of decentralized accountability, it creates a fundamental design imperative for everyone involved. The builders, the developers, the organizations deploying these agents. The source really hammers this point. We have to design transparent, human-centered agents.
And that means, in very practical terms, that the systems have to be able to explain their reasoning.
Right. No more black boxes.
No more black boxes. If the agent makes a critical decision, say, it prioritizes one legal strategy over another or it declines a big financial transaction, it absolutely must provide an easy-to-follow, auditable trail. It has to show exactly which data points, which rules, and which steps in its internal chain of thought led it to that conclusion.
And furthermore, they have to seek consent before acting on the most critical steps.
Yes. While the agent can autonomously plan out the whole sequence of events to reach the goal, any really high-stakes action, that final submission, a big money transfer, a permanent change to a database,
Yeah.
it has to have a human checkpoint, a point where the user reviews the planned action and gives explicit approval.
So it's this blend of oversight and autonomy that's really non-negotiable for building trust and ensuring safety.
And this necessary blend, it gives us the guiding principle for ethical deployment that was mentioned in our sources. Autonomy without accountability is chaos. Autonomy with transparency is progress.
That's a great line.
It is. The entire design philosophy from here on out has to be built on making the internal logic and the execution path of the agent completely visible and completely auditable.
Okay, so with those governance principles in mind, let's look to the future. Our sources offer 4 key predictions about the landscape of agent development over the next decade.
Okay.
First, we're going to see the rise of these highly complex agent ecosystems. Today, we mostly talk about a single agent working on its own.
In a silo.
Exactly. In the near future, we're going to have specialized agents that collaborate with each other in networks. For example, a litigation agent might realize it needs specific financial documents, so it sends a structured request over to the Treasury agent, which then has to coordinate with the archiving agent to get the files.
So we'll use standardized communication protocols to work together on these massive, complex goals that no single agent could ever handle alone.
What's the second prediction?
The second is that the focus on data security and privacy is going to accelerate the development of local and offline agents.
So not everything will be in the cloud?
Exactly. Right now, most of the heavy LLM processing happens on these huge cloud servers. The next big step is to have agents that run directly on your personal hardware, your laptop, your smartphone, maybe a dedicated chip inside your company's network.
And that keeps highly sensitive data, like personal health information or proprietary business strategy, off of external servers. It maximizes user control and privacy.
Third, we should anticipate the emergence of robust agent markets.
Like an app store, but for digital employees.
That's the perfect analogy. Companies and professionals won't always have to build their own agents from scratch. They'll be able to go to these specialized marketplaces where they can find certified, ready-made agents, a boutique social media growth agent, or a European GDPR compliance agent.
And you'll be able to buy them or rent them, and they'll come with performance reviews and guarantees that they meet certain standards.
Exactly. The professional world will start to be defined not just by the software you use, but by the customized collection of agents that you employ.
And that leads right into the final and probably unavoidable necessity: comprehensive AI governance.
It's inevitable. As agents move from being helpful tools to being essential components of our critical infrastructure managing finances, advising on medical treatments, controlling utility grids, governments are going to have to step in.
Telling new laws.
New legislative frameworks, for sure. We're going to see standardized laws that define liability, that set required certification standards for agents working in high-stakes fields, and auditing requirements to make sure these systems meet minimum standards for transparency and safety.
The market and the law are going to have to catch up to the technology very, very quickly.
They have no choice.
Oh.
And the sources are for this one powerful closing prediction that really brings this whole deep dive into focus.
Okay.
Within the next decade, every single profession, every lawyer, every doctor, every journalist, every consultant will own a custom AI agent.
Every single one.
It's going to transition from being a niche technology to being an essential daily professional tool. It will be as foundational and as necessary to your work life as your smartphone or your internet connection is today.
Wow.
So to just synthesize the core knowledge from this deep dive, we've defined AI agents as these autonomous goal-achieving systems. They're built on that iterative PRA, cycle, perceive, reason, act. Their explosion right now is being driven by these accessible no-code platforms and that big strategic shift to task-based workflows. Their internal structure relies on those 5 essential components, including the sophisticated reasoning engines and memory systems, and their capabilities are being supercharged by multimodal perception.
And we've seen that this transformation is already happening across law, finance, and healthcare. And the ethical mandate is crystal clear. For this to be progress, that autonomy must be paired with extreme transparency and accountability through auditable design. Your digital teammate is arriving, and it's being tailored precisely to your professional needs.
That's the takeaway.
Which leaves us with this one final provocative thought for you to consider as you reflect on this whole evolving landscape.
Okay.
If custom AI agents do become the essential, ubiquitous co-pilot for every single profession, and AI governance successfully establishes clear boundaries and certification standards for that autonomy, what happens to the fundamental definition of a profession itself? Where exactly does the human professional's ultimate irreplaceable value lie when the digital co-pilot is this capable and the human role shifts primarily to one of high-level strategic supervision and ethical oversight?
A very good question to ponder.
Thank you for joining us on this deep dive into the architecture and future of AI agents. We hope you feel thoroughly informed and ready to command your new digital teammate.